A group X present on benzene ring deactivates the ring for SE reactions. Most deactivating group among the following is directive influence of substituent. On that concept this question is based. And if we talk about the deactivating group, the most deactivating one is nitro group. Then this is the order of deactivating nature towards SE reaction we're talking about. NO2, after that there would be Cn, then CO, CH3, and after that there is the group that is F. In this case, the most deactivating is nitro group. That's why this is the correct answer. Let's take next question. Which among the following is an anti-aromatic species? Which have different species we have. And here, if you look at option 3, you will see that this is a planar molecule. Planar molecule with 4n plus 4n pi electrons. Means species should be planar. With 4n pi electron. If you look at the structure, there are 4 pi electron, and if it is so, then n value is 1, and that's why this is anti-aromatic. And yes, third option is the correct option for this question. Let's check next question. Now question number 88. A sample of 0.2 gram of organic compound was heated according to Zildahl method. The ammonia evolved just neutralized by 40 ml 0.05 normal H2SO4. The percentage of nitrogen in the organic compound is, for Zildahl method, we can calculate percentage of nitrogen by the simple formula that percentage of nitrogen is equal to milli equivalent of ammonia that's released into 1.4, and that is divided by the weight of the organic compound taken. We know that weight of organic compound taken, and we need to just find out the milli equivalent of ammonia, because this is a process of neutralization in which ammonia is neutralized by H2SO4. And the volume and the concentration of H2SO4 is given. We should know that milli equivalent of ammonia should be equal to milli equivalent of H2SO4. Now with the help of this we can find out the milli equivalent of ammonia, because milli equivalent of H2SO4 can be calculated by the given values. We know that milli equivalents are the volume multiplied by normality, and volume should be in milliliter. So 0.05 normal, and it is equal to 2 milli equivalent. These are the 2 milli equivalents of H2SO4, and definitely in this case milli equivalent of ammonia would also be 2. And on that basis, percentage of nitrogen would be equal to 2 into 1.4 as per the formula, divided by the weight of organic compound taken. What was that? That is 0.2, and this is equal to 14%. And yes, the correct answer is given here in option 4, that I'll choose as the correct option. Let's take question number 89. Most acidic species among the following is. Acidic species are those species which have the nature to lose H plus ion or the proton, and after loss of proton they form their conjugate base. If their conjugate base is stable, then definitely they have more acidic character. But if conjugate base is less stable, then in that case they will not show acidic nature. So if we talk about the species given in option 1, 2 and 3, here is the conjugate base that is formed, but that base is not stabilized. They will show less acidic character. But if we talk about the compound given in option 4, this is the compound. There is hydrogen atom. It will lose its proton, and these electron will come over this carbon in this position. Now this is the species, and now In this case, it is a planar molecule with 4n plus 2 pi electrons. Because in this case 6 pi electrons are there, it means it is following Huckel's rule. It will show resonance. It is stabilized by aromatic nature, and that is why, being stable conjugate base, the species which is 1,3-pentadiene is the species which is most acidic. And on that basis, I'll choose option 4 as the correct option. Let's take last question. Question number 90. Most stable free radical is. In these given free radicals, I'm just arranging them in the correct order of their stability. If we talk about this CH2, CH, CH2, this is most stable. After that, there is the turn for this free radical. Then there is this one, and after that there would be methyl free radical. This is the correct order. Now if you look at this order, you will identify that most stable free radical is here. That's given in option 1. And that's why option 1 is the correct option. I hope all the questions those we discussed during today's session are clear to you. Best of luck for your result. Thank you so much.